Hey everyone, welcome back. SV Math Teacher here. Remember to smash that subscribe button if you like what you see. Now, today's short video is on scatter plots and trend lines, and if you watch the first video I had on scatter plots, you almost don't need to watch this one. They're very, very similar. A trend line is simply a line that we're going to draw through the data points in a scatter plot in order to estimate the trend. And we use them to try to make predictions. So the last time you saw a video from me, I was using a highlighter tool to decide whether something was positive, negative, or if there was no correlation. I'm going to use that same skill today, but then I'm going to draw a line through it. That line will be called a line of best fit or a trend line. It's not called a line of regression because a line of regression indicates there's some sort of math being involved in the actual drawing and forming of the line. That's something a calculator would do. You and I, we're going to estimate. So here's the idea. How to use bivariate data. Bivariate data is simply data that is a relation, right? It might be a function, but it's just a relation. There's two pieces of data. So we're going to go collect the data. You would always do that first. Generally speaking, if you're looking for a relationship between two pieces of data in order to predict what comes next, we would then graph that data. We're then going to create a trend line. This is the step we're on for today. And then the fourth step would be use that trend line, not the data. This is key. You use the data to make the graph. You use the graph to make the trend line. And then you use the trend line only. At that point, you could throw the data out. You use the trend line to make the prediction. So key component there, right? I wrote a little side note here. Some lines will be linear. Some lines will be nonlinear. And some graphs will ultimately have no correlation whatsoever. So we don't draw a line there. That will happen as well. So let's take a look at two local pools, right? Again, making up this information. Let's imagine that we charted the number of attendees at our local pools pre-COVID at two different towns, Quakertown and Hellertown. On the left-hand side, I have temperature as my input, my pool visitors as my output. I have a series of black dots which must represent maybe different days throughout the summer. And in the past, I would have kind of highlighted that data to decide whether it was positive or negative. See how that blue line goes almost right through the center of that highlighted feature? That means that that blue line is a good trend line. It means while it misses some dots for sure, that blue trend line isn't touching here and it's not touching this and this. What it is it shows a trend or kind of an average of the data. So the trend line is meant to show an overall picture of how the Quakertown pool does at different temperatures. Over here, the Hellertown pool does the same thing. The only difference in the Hellertown pool is you might recognize that while there is still positive, the data is much more spread out. So I have a positive correlation. I still have a blue trend line. It still goes through the center of my highlighting kind of region. The only difference is going to be that when we're comparing the quality of the trend line, the trend line on the left is going to be more accurate than the trend line on the right because the data itself is more tightly packed. The more strong the correlation, the easier it is to make a trend line. The weaker the correlation, the more difficult it is to make an accurate trend line and to predict off of that. But let's get moving here. It's also worth showing you that there are trend lines that exist that are nonlinear. We have two examples. One of them is objects thrown into the air. How long the object is in the air may have an impact on how high the object went. And you notice I have lots of data. There is, while it's not a linear relationship, there is definitely a trend we observe. So once again, that blue line goes kind of in between the data to try to generally represent the data. Since we can do this, we would refer to this as a non-linear trend line. Same deal over here. This was kind of a scary one related to COVID, but we saw this on the news all the time around March and April of 2020. That COVID cases were going up. The term that was used was exponentially, non-linearly. So yes, there was a trend. Yes, there was a pattern. Yes, we could predict from it, but it was non-linear. Now, there's one last piece that I thought I should show you. Here's an example, and you've seen this before, that if you try and highlight, this data is so spread out that the shading that I just did there is no more accurate than the shading that I do here, right? There's really nothing to go on. Because there's nothing to go on, I wrote down, while we might expect the cost of a new car to impact its reliability, because that's what this is showing, the data that we have graphed suggests that there's no relationship. If there's no relationship, there is no line. And if there's no relationship and there's no line, then we cannot make predictions in this example that the cost of a new car has any impact on the reliability of that car. So, generally speaking, use a highlighter tool to help kind of gather your data together. Your trend line should go through, like I have here, and like I have here. Your blue trend line, in my case blue, should go through that highlighter tool. And at that point, for what it's worth, we use the blue, in my example, blue line to do the predicting, right? Last 10 seconds of the video, here's what I mean by predicting. Let's go back to our first example in Quakertown. If we say, well, what do we think happens if the temperature goes to 95 degrees? Well, 80, 85, 90. So 95 is probably right here. I'm going to imagine going up is my 95 line. I'm going to imagine my trend line continuing. I'm going to make it a little bit fatter so it lines up. And then I'm going to shoot over. And it looks like I should expect, if my temperature goes up, I should expect almost 1,000 people to attend. That's how you use a trend line to predict.